Okay, so we're going to be looking at this problem right here. It says the position of a particle is given by the equation x of t equals t cubed minus 6t squared plus 9t, where t is measured in seconds and x is in meters. Part A asks us to find the velocity at time t. Well, we know the velocity is equal to the derivative of our speed function, which in this case is x prime of t. So, to find that, we can write x of t out first. And then use the power rule to find velocity. So we're going to get 3t squared minus 12t plus 9. Part B asks, when is the particle moving right? Well, we know that the particle is moving right when velocity is greater than 0. So to find this, we can plug our equation from part A of velocity at time t into our calculator and then look at the table of values so that we can make a little number line here. And we're not really interested in looking at negative time, so we'll start with t equals 0. And if you look at your number line, you'd see that from 0 to 1 second, the value is positive. Even though it's decreasing from 9 to 0, if velocity is still, if the y value is greater than 0, it still means that it's moving in right. So then we see from 1 to 3 seconds that the values become negative. And then from 3 on, we see that the values are positive again. So we see that it's moving right. At intervals 0 to 1 and 3 to infinity. Part C is asking us to find the total distance traveled by the particle in the first 8 seconds. Well, to do this, we know that we need to look at each of the intervals that we found for positive and negative travel in Part B, and then use those intervals, find the absolute value between the differences. So, to do this, we'll start over here. And we need to plug our equation in for x of t because we're looking at position and not displacement. So the first interval we're going to look at is x of 8 minus x of 3. The next interval will be between x of 3 and x of 1. The final interval will be x of 1 minus x of 0. And remember that we look at the absolute value because we're looking at we're not really looking at the direction that it's traveling, rather just that it's moving from time 0. So once we plug each of these into our calculators, we see that for the first one we get 200, for the second one we get 4, and for the third one we get 4 as well. So we see that our answer has traveled 208 meters in the first 8 seconds. Part D asks, when is the particle slowing down? Well, we know that the particle is slowing down when velocity is less than 0, while acceleration is greater than 0. Let me rephrase that. We know that velocity is greater than we know that the particle is slowing down when velocity is greater than 0, while acceleration is less than 0, and velocity is less than 0, while acceleration is greater than 0. So in order to find the acceleration of the particle, we need to find the equation for acceleration. And basically, we're just going to do kind of what we did in part A, take the equation of v of t and find a of t, because we know that a of t is just the derivative of v of t. So to find a of t, we're going to get 6t minus 12. So what can be really helpful in this situation is if we make a number line for acceleration like we did in part B for velocity. So what we'll do is we'll plug in a of t, and we'll look at the at the equation. Once we plug it into our calculator, we can look at the table. So we see that from 0 to 2 seconds, the acceleration is negative because the values of a of t are negative values. Then from 2 on, it's all positive values. So we have to kind of look back at v of t here. So we can see that, let me write in a different color here. I'm going to put v of t in green on this acceleration timeline. So we said from 0 to 1 in v of t that it's positive. So we definitely know that for this interval, it's slowing down. But also from 1 to 3, velocity is negative. But acceleration from 2 to 3 seconds is positive. But from 3 on, velocity is also positive, so we know that it's speeding up there. So we have to look at the difference. So we know we see a difference from 0 to 1 seconds and from 2 to 3 seconds. So for part D, we can say that it's slowing down at intervals of 0 to 1 seconds and 2 to 3 seconds. And that's it for this problem.